Okay, in this session, we're going to learn the graph of other trig functions. What does that mean? We have learned 6 trigonometric functions, and we already learned the graph of sine and cosine. And you can, if you remember, the sine function looks like this. Okay, and each period is 2 pi, and here's a 0, maximum 1, minimum -1, right? And continue. And continue. So this is the y equals the sine function, sine x. And the other one is y equals the cosine function. It looks like this. The period is also 2 pi, and here is 1, -1, and okay. So the period is 2 pi, but it starts from the highest point and go down and up. Okay, and this one starting from 0, 0, go up. This is a sine, and this is a cosine. It's x, just make it more accurate. So this is the graph that we learned earlier for the last session. Now we're going to learn the next, which is y equals tangent x. Okay, y equals tangent x. Tangent is sine over cosine, right? If you remember that you have a little chart like when x is 0, when x is 30 degree, or pi over 6, 45 degree, or pi over 4, 60 degree, pi over 3, and a 90 degree, pi over 2. If you have that, and what is the tangent of x? Tangent x or y. That is a 0. And then when it's a 30 degree, do you remember this? It's root 3 over 3. And here's 1, here's root 3, and here is undefined or does not exist. All right? And so think about the tangent is kind of like the slope of the line, right? So if it's a 0, then slope is a 0, and go up gets higher and higher, and here the slope is 1, so that's 45 degree. And then when it goes higher and even close to 90 degree, that slope is super big. And then when it's 90 degree, then it's a vertical line, so the slope is undefined. Then what happened? It's a very negative, the slope, and then -1 and a 0, right? And then when it keep going, did you notice that? It's positive, right? It's a 0, then positive, and then +1, and things like that. So the graph looks like this. This is x, this is y, and here's a 0, and this is pi over 4, this is a pi over 2, here negative pi over 4, and here's a negative pi over 2, and here's a negative, 3 pi over 4, and here will be 3 pi over 4, and so on. So what it says is this, 0, 0, that's one of the point. And then here's a 1. Remember pi is a 3.14 something divided by 4. It's like a 0.7 whatever, but we don't really need to scale both x and y. This 1 doesn't need to be that 1, so it doesn't really matter. We just label that as a 1, and here is -1. So when x is a pi over 4, which is 45 degrees, the slope is 1, and it's a -1 for the negative 45 degree. For the no, I shouldn't say that. When it's a negative, yeah, -45, so that's a -1. All right, and then so it gets higher and higher, and by the time it reaches to 90 degree, it's undefined. So let me put the dotted line here because I believe that there should be no y value when x equals that. Okay, guess what the graph would look like? Because without just okay. And then the same idea, this and this. So I have periodical. Okay, same thing. All right, now what can we tell by this graph? This is always an increasing function. This is the graph, okay? And what is the period? See, that's from negative pi over 2 to positive pi over 2. This period is this number minus this number, that's pi. So after every pi, here's pi. After every pi, the graph repeats. So what we can tell is for the tangent function, we have the period, very important, pi. Period is pi. And what is the domain? Domain X can be all real numbers except all the dotted line thing, because when X equals to that value, our Y is undefined. So how do we express that? It's going to be whatever the multiple of a pi plus a pi over 2. So except X equals n pi plus pi over 2. Or you can simply say X cannot be n pi plus pi over 2. It could be n can be any integer, so 0, positive 1, positive 2, negative 1, negative 2, and so on. And then as long as it's a multiple of pi, then you plus pi over 2, which means between pi, 0 and pi, and 2 pi, and 3 pi, and in the middle, that's your vertical line, vertical dotted line, that's X cannot be that number, so that's your domain. And the range, let me just keep going, and the range will be all real numbers. Or you can say negative infinity to positive infinity. See, that's what the Y value can be, right? So after domain and range, let's look at this. Is this an even function or odd function? Odd function means the picture, the graph, got to be symmetric along this y-axis. Of course, this is not. For odd, that even function, but for odd function, the graph should be symmetric along this 0, 0. So it is. So it's an odd function, which means f of a negative x is negative f of x. So that's the definition of the odd function. And the one more interesting thing here, instead of having, do you see this graph, x equals the sine and the cosine, they're continuous, right? But this is not, it stopped. And also it goes to here and goes up and up and up, very, very close to this line, but not equal to. Those dotted line, we call that asymptotes. Asymptote. That is when x equals n pi plus pi over 2. That's your asymptote. So for this graph, this y equals tangent x has asymptotes. So that is everything I think we need to know for this. I think this is might be too big, so it's hard to tell, right? All right, so we pretty much done for the sine, sine, cosine, tangent. Now we're going to continue with the cotangent. Y equals cotangent x. Again, x, y, 0, pi over 2, pi, 3 pi over 2, 2 pi, 1, negative 1. I just draw that easily. So it's a negative pi over 2, negative pi, negative 3 pi over 2, etc. And you're going to do exactly the same thing as that, right? X and y equals cotangent x. Could be 0 and a pi over 6, 30 degree, pi over 4, 45 degree, pi over 3, 60 degree, and a pi over 2, 90 degree. Cotangent is cosine over sine. All right, so what is when x equals 0? When x equals 0, your sine x is 0. Therefore, this does not exist. Okay, do you remember that? And then when x equals pi over 2, cosine is 0. Sine is cosine 90 degree is cosine is 0 and sine is 1, so it's 1 0 over 1, so that's 0. And this is root 3 over 3. This is 1. This is root 3. Okay. So if you graph that, so pi over 4, you get a 1. So it's pi over 4, you get this point. All right. And when x equals 0, y does not exist. So you don't have anything along this y-axis. And when x equals pi over 2, you get a 0. And then guess what? This is going to be your graph. Of course, if you like, you can just find the exact point and then graph it. Ah, yeah. And this. You see, it looks like this. It's a decreasing function, isn't it? Okay, now let me ask you, what is the period? You can easily tell the period is also pi. Now, quickly reminder. For sine and cosine, the period is 2 pi. For tangent and cotangent, now you get the period is pi. Okay, different, okay? It's a decreasing function. And what is the domain? Domain, which means what x value can be, right? And x can be anything except those points. Okay, so x can be all real numbers except n pi. As long as it's 0, pi, 2 pi, 3 pi, which is like a 0 pi and a negative 1 pi and whatever. So that is x as long as it's not a multiple of pi, that's your domain. And your range, again, negative infinity to positive infinity, because y can be anything. Domain and the range. Is this odd or even? Odd or even? Okay. So is this a graph symmetric along this 0, 0? Yes. So that's an odd function. Odd. So which means f negative x equals negative f of x, which is the same as the tangent function. Okay. And obviously it's not even. Okay. What about the asymptotes? Asymptotes. This is when x equals n pi. That's your asymptotes, all those vertical dotted lines. All right, so this is the tangent. This is the cotangent. Looks pretty, isn't it? Okay. Let's do this. Y equals secant x. Complicated. What is secant? That's 1 over cosine, right? Okay, so here's a 0. And here's a 1. Here's a negative 1, 0. And pi. And 2 pi. 3 pi. And 4 pi. Now, I use different color. Let me just use the little red color to show the cosine. Cosine. Let me just make it a cosine x. Okay. Cosine is this. That. I'm sorry. Here. Should be here. I forgot where I do that. Let me just. That's my cosine. Okay. When I take the reciprocal of it, what is the reciprocal of 1? It's also 1, right? Okay. What about here when it's like when the y is 1/2, reciprocal will be 2. Okay. And then when it's closer and closer to 0, the reciprocal becomes like a positive huge number. So I get this. Okay. And when it's 0, I get asymptotes because I cannot take the reciprocal of 0. Oops. Oh, I'm so sorry that it should be straight. So there's that. And when it's a pi, cosine of pi is negative 1. I take the reciprocal of it, so it's still negative. That. My black curve graph. It's a secant because we take the reciprocal of the cosine value. All right, now domain. Domain is x can be anything except here, 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 and here. What are those? Those are x cannot be n pi plus pi over 2 because at those x values you have the cosine will be cosine of this is 0, so you cannot take the reciprocal. Therefore, the secant function, the domain is x cannot be that. And interesting, range. Range is what the y value can be. You see, it can be from -1 to below or +1 to above. So that's from -infinity to -1. It could be -1, +1. So that's why I take bracket instead of a parenthesis. So 1 and to +infinity. That's the range, domain and a range. Okay, is this even or odd? Is this a symmetric along the y-axis? Yes, it's even because f of x is the same as f of negative x. Okay, it's even because it's symmetric along this y-axis. And the last one, are there any asymptotes? Asymptotes? Yes, when x equals n pi plus pi over 2. Interesting, isn't it? Okay, secant, and then the next one is a cosecant. You tired? And remember that is 1 over sine. Okay, I'm going to do a better job this time. So I will show you, this is x, this is a y, here's a 0, here's a pi, here's a 2 pi, here's a 1, here's a -1, and that's negative pi, -2 pi. Okay, for sine function, I'm going to use the red color, the sine function. Okay, sine function goes like, see? So I'm going to do a better job this time. Sine. That, oh, it's not very good. Okay, so there it is. Okay. That's my sine function. When I take the reciprocal of it, you can imagine that for all the zeros, you cannot take the reciprocal. This is a 3 pi. And then, so it's going to look like this. That's my graph. Oh, here, more. So that's my graph of y equals cosecant x. You see how I do that? You always go back to sine and cosine. Then it's going to be super easy. Now, what is the domain? X can be anything except here, 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 here. So x cannot be a multiple of pi. Range, it's the same, right? From -infinity to -1, union, +infinity to +1 to +infinity. Is this even or odd? It's not even, and it's odd. See, it's symmetric along this point, right? So it's an odd function because f of x equals negative f of. Okay, it's an odd function. Are there any asymptotes? Yes, all the dotted line. So when x equals n pi, that's your asymptotes. So far we know all the graph for those functions. Okay, it's really hard to put them together, but I want you to think sine, cosine, and then first of all you got to know the shape. Okay, the shape of it, the key point, 0, and then 90 degree 1, 180 degree or pi 0 and go back. So that's a sine. That's the easiest one. Cosine start not from the center. Cosine start from the top. Okay, and then tangent goes up, passes through 0, 0, and has a period of pi. Okay, and there's a key point. See, 45 degree and a negative 45 degree. So 45 degree tangent is 1, negative pi over 4, or negative 45 degree tangent is negative 1. Yeah, that's a key point. So that's the shape of it. And the cotangent graph looks like this. It's a decreasing function. The period is also pi, okay? And the domain is all real numbers except a multiple of pi. Range is from negative infinity all the way to positive infinity. Again, this is an odd function, and there are symptoms. Okay, secant and a cosecant. Here's the top is the secant, the bottom is cosecant. I think. Okay. Oh, there's one thing I forgot. What is the period? You see, what is the period? Starting from here all the way to here, right? That's after 2 pi. It repeats. So period is 2 pi. And this one, same thing. The period is also 2 pi. So now you see for sine, cosine, tangent, cotangent, secant, and cosecant. Okay, so what I ask you to do when you have a chance, you can just do this. Y equals sine x, cosine x, tangent x, cotangent x, secant x, cosecant x. Graph. Period. Domain. Range. Okay. Are there any even or odd? And asymptotes. Okay. So maybe I can do this quickly so you get the idea. The sine start from here like that. Okay. And the period is 2 pi, right? The domain is from negative infinity to positive infinity. The range is from negative 1 to positive 1. Is this even or odd? This is odd. Okay. And asymptotes, none. Cosine goes like this. Okay. And the period is also 2 pi. The domain is the same. The range is also from negative 1 to positive 1. And is this even? And what about asymptotes? Asymptotes, none. Okay. And tangent is this. Okay, interesting, right? And the period is pi. The domain is x cannot be n pi plus pi over 2. And the range is from negative infinity to positive infinity. Even or odd? This is odd. And what about asymptotes? That means x equals n pi plus pi over 2. Okay. And the cotangent looks like this. And here's pi. So the period is pi. Okay. And x, as long in the domain, as long as it's not a multiple of pi, you're okay. And the range is from negative infinity to positive infinity. And is this even or odd? This is odd. Okay. And the asymptotes means x cannot be n pi. All right. And the secant, that's my little c. The secant x. Secant x. Sorry, not sex. Secant x. Okay, secant is the reciprocal of that. So the graph look like this. The graph look like starting from, see, from that, and this, and this, and this, and that, like that. Okay. So the period is also 2 pi. The domain is x cannot be here, which is when x equals when the cosine x is 0, so that's n pi plus pi over 2. And the range is from negative infinity to 1, union from 1 to positive infinity. Okay, so that's the range. And it's even or odd. This is even. And the asymptotes, x cannot be n pi plus pi over 2. And for the next one, cosecant function, which is the opposite of this. So you have asymptotes. You get this, and this, and this. Okay, that's cosecant. See the difference between these two? And the period, again, is 2 pi. And the domain is x cannot be a multiple of pi, so x cannot be n pi. And the range is, again, from negative infinity to negative 1, union 1 to positive infinity. Is that even or odd? This is odd. And the asymptotes is x equals n pi. Sorry, here is equal. That's a asymptote. So maybe you can just do a snapshot here. Let me just do a better job here. Sorry. Secant x. Sorry for that. All right, so this is how do you graph all those 6 trigonometric functions. The next thing is, again, that ABCD thing. You can graph by doing transformation. For example, I will give you one example, okay? I give you y equals a tangent b x minus c plus d. I ask you to graph this. Let me see what are the example that I want you to do. I think I have some idea somewhere. Just don't remember where did I put it. All right, I just made it up. Okay, so let me just graph. I ask you to graph y equals 2 tangent 2x minus pi over 3 plus 1. I just made this up, and I need you to give me A, B, C, D. And you can see this is A is 2, and this is amplitude, right? It's 2. Now B is the collection of this 2, but you have something behind, so you get a 2x minus pi over 3. You need to write that as 2x minus c. You have to write it like this, so you can find what is a c. Several ways to do it. One is because you factor 2 out, so the inside you have to divide it by 2. Therefore, your c will be pi over 6. Or you can say 2 times c is pi over 3, isn't it? Because if you multiply this 2 inside, you get 2x. You multiply by 2, this negative, negative, we don't worry about that. So 2 times c is that. So my c will be pi over 6, because once you divide it by 2, and your d is 1. So b equals 2, my c equals pi over 6, and my d equals 1. Do I get A, B, C, D? Okay, so let me just write it like this. Y equals 2 times the tangent 2 times x minus pi over 6 plus 1. All right, I need you to graph this guy. When you graph this guy, you start from the parent function. What the parent function look like? The parent function look like this, isn't it? This is the parent function. Okay. Now, what you should do first? You should do a lot of things. This is the multiple of 2, which means the how do I call that? The amplitude, you're going to stretch this by 2. But once you have a b, you have a new period. My period is the parent function's period. This time is pi, okay, divided by b, so which is pi over 2. So my new period, the old period is from here to here, right? The old period is pi, but my function's period will be just the pi over 2. Okay, so I would do, if I stretch this by 2, do I get here? When it's a 45 degree, I should get 2 instead of having 1. So my graph, oh, hold on, let me see. How do I use this 2? I make it, so this is a vertical stretch by 2. That's how it works, right? Okay. And what about the period of this one? Let me change another color. Okay. What about this 2? This gives you the period. Right now the period is pi, so I need to squeeze that. Okay, so therefore I squeeze that like a squeeze horizontally. Okay, and then this minus pi over 6, I gotta move this point to somewhere to positive pi over 6. So I need to find, here is pi over 6. My 0, 0 move to here after I do this. And then 6. And then so you moved. But remember when you squeeze, that goes to 45 degree. So your asymptotes become positive and negative 45 degree. But then you have to, so you go to negative 45 degree and a positive 45 degree. I use a degree, which make it a little easier, okay? Because right now here is 90 degree, here's negative 90 degree. I know a lot of people still get frustrated about those radian measurement. But then after I squeeze, I move to the right by 30 degree. So this becomes negative 15 degree, and this becomes 75 degree. Make sense? So I squeeze everything to the right by 30 degree. So I did this, 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 and then I go plus 1. So I go up by 1. But remember here, you in the middle used to be 1. You already multiply by this 2, you get a 2. So you multiply, you add 1, so your middle should be 3. But we worry about that later. And this is 0, 0. You move to the right by 30 degrees. So let me just say 30 degree, and then you move 0, 0 to here. So your graph will look like this, starting pass through this. And then your period is from, this is a 30, so that's negative 15. And then this is a 30, here's a 60, here's a 75, here's a 75, here's a 60. Okay, so pass through this. And the middle guy used to be 1, and then now we double that, we get a 2, and then we plus a 1, we get a 3. And this point goes up by 1. So this, the middle of this interval, the middle guy, I have a negative 1. I double that, I get a negative 2, and then I increase by 1, so I get a positive 1. So my graph look like this. So that is only one period. If I ask you just give me the graph of one period, that's it. If I ask you to do more, so this is negative 15 degree, and this is a 75 degree. Okay, so the period is 90 degree, which is pi over 2. And of course, if you do one more, so you're going to add a 90 degrees, you get 165 degree. And then the middle goes up by 1. The middle again becomes a 3. the middle again goes -1, so you just repeat the graph. Okay, so if I ask you to graph 2 period, and that's it. Now you see how all those things played when you do the transformation of the graph. Okay, so I try not to give you a so hard problem, but this shows you how to graph when you have like the general ABCD thing. And I don't need to do for the cotangent, secant, and the cosecant. I think those are very similar. As long as you know the basic idea about what ABCD plays the role, then you should be able to graph them. Okay?